Okay, just doing a new video on solving things like sine of 2x is 1 and things like sine of 2x is 0, for example. So the best thing to do with these, if sine of 2x is 1, sine of 2x is 0, or sine of 2x is negative 1, best thing to do is to sketch the sine curve. So I'm going to sketch a sine curve, and I've got one there. And that's 2 pi, an ordinary sine curve. Just sketch the curve y equals sine x. All right, don't sketch 2x, just sketch sine x. Now, if you're asked to solve these from 0 to pi to 2 pi, then because you're asked to solve sine of 2x equals 1, 0, or negative 1, you need to change your domain by multiplying everything by 2, and you have to solve from 0 to 4 pi. So what you've got to do, remember sine, normally we say sine of what is 1. So to be able to do what sine of what is 1, you look at an ordinary sine curve. Now I can see from this sine curve that sine of 90 is 1. So my first solution for 2x would be 90. But I do have to do from 0 to 4 pi if I'm solving anything in terms of 2x. So I need to continue my sine curve up to 4 pi. So because we're saying sine of what is 1, you can just treat this as an ordinary sine curve. So sine, I know that sine of 90 is 1, so I can replace this 2x with a 90, right? The next place where I've got 1, if that's 2 pi, this is 3 pi. It's 2.5 pi, which is 5 pi on 2, okay? So looking at the sine x curve between 0 and 4 pi now, I have to look at it 4. You just see where does sine x equal 1, or sine of what is 1, and it's sine of 90, or 2 pi on 2, and sine of 5 pi on 2, or 2.5 pi. Now to solve for x, I just divide by 2. Okay? Now using that same curve, I can solve sine of 2x is 0. So sine of something is 0. Just draw the ordinary sine curve, and here are my answers. Where does the sine curve equal 0? I've got 5 solutions. I've got 0, pi, 2 pi, 3 pi, and 4 pi. And that is the solution for 2x. So now I divide by 2, and I've got those 5 solutions, okay? Now you can test by substituting any of these in. When x is 0, you get sine 0, that's 0. When x is pi on 2, 2 times pi on 2 is pi. Sine of pi, that's my normal sine curve, sine of pi is 0, so yes, it works. And here, just looking at the solutions to sine of 2x is negative 1. Don't worry that it's sine of 2x, just draw an ordinary sine curve, and where does this equal negative 1? Well, I can see it equals negative 1 between pi and 2 pi, so that's 1.5 pi. Which is 3 pi on 2, and I can see it equals negative 1 halfway between 3 and 4 pi, which is 3.5 pi, which is 7 pi on 2, and now just dividing them both by 2. Okay? Now the reason I needed to draw 2 lots of the sine curve is that whenever you're solving for 2x, you need to double the domain. So now we will do some other questions. We'll just look at the one that we did in class. Sine of 2x plus pi on 6 equals negative 1. So if you're asked to solve something like this, don't worry that this is complicated. Just draw an ordinary sine curve. Okay, now you're asked to solve that for 0. This one was for negative pi less than or equal to x less than or equal to pi. So if you're doing 2x, you have to double them all. And if you do 2x plus pi on 6, you'd have to add pi on 6 to each of these. So negative 2 pi plus pi on 6, 2x plus pi on 6, and 2 pi plus pi on 6. Now, I have to sketch the sine curve. And I have to make sure that I go to 2 pi plus a bit more. All right? So that's 2 pi, pi, 0. And I've got to go to negative 2 pi, but not as far as negative 2 pi, so I stop about here. So I stop about there, okay? So that's negative 2 pi there, but I'm before negative 2 pi. That's negative 1 and 5/6 pi. Okay, so I'm starting from there and finishing here. Okay, so I read off my solutions. Where does it equal negative 1? Well, I've got two spots where sine of something is negative 1. So don't draw the 2x plus pi and 6 curve. Just draw the ordinary curve, okay? So I've got that 2x plus pi and 6 could equal, where is it negative 1? Well, it's halfway between 0 and negative 90, which is negative 45. So it's negative pi on, halfway between 0 and 90, which is, yeah, between 0 and 180, which is 90, which is pi on 2. And this is halfway between 90 and 180, which is 270, or it's 1.5 pi, which is 3 pi on 2, okay? So they are the solutions for 2x plus pi and 6. So we've got halfway between 0 and 180, which is negative 90, halfway between pi and 2 pi, which is 1.5 pi. So now we just subtract our pi on 6 from each of these. And to do that, that's negative 1/2 minus 1/6. You could do it on your calc, or that's 3 pi on 6. I think it's negative 4 pi on 6. And this one would be times 3, 9 minus 1. That one's positive 8 pi on 6. And then we divide by 2. And we get negative 4 pi on 12 and 8 pi on 12. And you can simplify those, and you would get negative pi on 3 and 2 pi on 3 for your solutions. I'm just going to check these answers here. They look fine, okay? I'll do one more. So if you're asked to solve something like cos of, I don't know, x on 2 is 1 for negative 2 pi less than or equal to x less than or equal to 2 pi, okay? So again, it's cos of something is 1, so you want to draw a cos curve. But we're asking for x on 2 here, so we have to divide everything by 2 in our domain. So we just draw a normal cos curve, which looks like that and like this. But how far do we draw it? So this is 0. The normal cos curve, that's up to 2 pi there. But I don't want up to 2 pi. I only need up to pi. And that's negative pi. That's negative 2 pi. I only want it, so I'm going to outline the bit I only want between negative pi and pi. I just want this bit in pink. Okay, so to do the solution for cos of x on 2 is 1, it only equals 1 in one position here, and that's at 0. So I get x on 2 is 0, therefore multiplying by 2, x is 0. But if I ask you to solve cos of x on 2 is negative 1 for that same domain, all right, from negative 2 pi less than x less than 2 pi, because I'm dealing with x on 2, I have to halve all these. I still want from negative pi to pi, including those. Where does it equal negative 1? Well, I've got two values at negative pi and pi. Notice I'm just drawing the y equals cos x curve, not the cos x on 2 curve. So my two solutions for x on 2 are negative pi and pi. And now to get my final solutions, I multiply by 2, okay? I get x is negative 2 pi and 2 pi. And for the last one, if I asked you to solve cos of x on 2 is 0, for that same domain from negative 2 pi to 2 pi. So, but then you have to divide everything by 2. You only want the graphs from negative pi to pi. That's a negative. So where does the cos curve equal 0? I've got two spots there and there. And those spots at 0, negative 180. This is negative 90, which is negative pi on 2. And this is positive 1/2 pi, or pi on 2. And they're the solutions for x on 2. So the solutions for x, multiply both of these by 2 and you get negative pi and pi. So they're your two solutions, okay? So please, if you're solving anything like cos x is 1, cos x is 0, cos x is negative 1, just draw a normal cos curve. Don't draw the changed cos curve. The thing is, if you do draw the changed curve, you read the x value straight off. But I think it's easier to just draw an ordinary cost curve and read off your values, but they are the values for x on 2, and then fix it up to make it x by multiplying, in this case, by 2. And up here, to work out x, we had to divide by 2. Okay?